All right, hello everybody. This is Miss Piekarski with another video. This one is all about triangles. We're going to have a very huge unit we work with triangles over and over and over again. We're going to do a lot of incredible things with them. So before we get started, let's go over some basics on how we generally label our triangles and how we round the triangles. First of all, I hope most of you guys recognize that anytime you have this little box in the corner of your triangle, that means you have a right triangle. Most of you already know that. Another thing, whether we have a right triangle like this or a non-right triangle like this, you always label your vertices or your angles with uppercase letters. In this case, we are using A, B, and C. So your vertices or your angles are always uppercase letters, and then your corresponding sides should be the same letter but in lowercase. So notice that my C, lowercase c, is directly opposite to angle C. Lowercase b is directly opposite of or directly across from angle B, and then angle A is directly across from or opposite to side A. Okay, and this works no matter what type of triangle you have, whether it's obtuse, acute, what's some of the other ones, isosceles, equilateral, doesn't matter. Your sides and your corresponding angles should have the same letters. Okay, another thing you should know when you're finding the length of your sides or the degree of your angle, on the side lengths you want to round to 2 decimal places if you have to do any rounding, and then on an angle you need to round to 1 decimal place on the degree. Okay. Also, most of you have realized that this is not in your notes. You should go ahead and jot these notes down either on the margins or on the back of your worksheets. Alright, so let's get started by looking at some of our special triangles and the Pythagorean theorem. Everybody knows the Pythagorean theorem and knows how to use it. A squared plus b squared equals c squared. A lot of times when you're using this to solve right triangles, you start with 2 sides and you are looking for the other side. Okay? However, in some cases you actually only need 1 side length, and then you can find the other 2 side lengths. Those special cases are when you have a half of an equilateral triangle and when you have half of a square. Okay? These are also called 30, 60, 90 degree right triangles, or 45, 45, 90 right triangles. So what you do is, if you know the shortest side is x, it could be any number, but if you know the shortest side, then the longest length, or excuse me, the longer leg, you're just going to multiply by the square root of 3. The hypotenuse gets multiplied by 2. So you start with x in all 3 cases. The hypotenuse you multiply by 2. The longer leg gets multiplied by the square root of 3. So this is for every 30, 60, 90 degree angle, or triangle, excuse me. Now with the 45, 45, 90 degree triangles, if one leg length is x and the other leg length is just going to be x as well. And then the hypotenuse, you're multiplying x by the square root of 2. Those are always what you will do if you have a 45 degree triangle or a 30, 60, 90 degree triangle. Alright, let's look at some examples. At this point right now, I just want you to take my word for it that that's what you're going to multiply by. Later on in this video, I'll show you, or I'll prove why or how that is the case. Okay, so in this example, we know the short side is 8 centimeters, and we need to find side B and side C. Because this is a 30 degrees here and 90 degrees here, I know that this angle is going to be 60 degrees. How do I know that it's 60 degrees? Because when you add up all the angles in a triangle, they always equal 180. Okay, so if you have 90 plus 30, that gives you what, 120? Subtract 120 from 180 and you're left with 60 degrees. So My other angle needs to be 60 degrees. Now, when we have the 30, 60, 90 triangle, my long leg, multiply 8 by the square root of 3. So my answer is just going to be 8 times the square root of 3. If you had a calculator, you could plug that in, round it out, and give me a rounded answer. But most of the time in my class, I prefer you just to leave it like this. And most of the time in your college classes, your professors are going to want you to find the exact answer, leave it as 8 times the square root of 3. Don't give me a rounded answer. Okay, and then C, you just multiply it by 2. So 2 times 8 equals 16. Okay, so that's pretty easy when you have the shortest leg. What happens when you don't have the shortest leg? Maybe you have the longer leg. Let's work backwards. So C is going to be 2 times x, and A is going to just be x, and B is going to be x times the square root of 3. So if you set those all equal to what they equal, then we have x times the square root of 3 equals 9. So then I know that x has to equal 9 divided by the square root of 3. Now, most of you say, man, that's a really crazy answer, but I don't have to plug it into the calculator, so I'm going to leave it like that. And yes, technically you're right, that is the right answer, but if you wrote that answer, your college professor would mark it wrong, and she would not explain why it's wrong. Speaking from personal experience, I kept getting it wrong over and over again, and I said, I know I did the math right, why is it counted wrong? And she said, well, you cannot leave a radical in the denominator. It's against the rules. And I said, what rules? I didn't see a copy of those rules, but she said it's against math custom to leave a radical in the denominator. Okay, so anytime you have that, the easiest way to get it out is multiply both the numerator and denominator by your radical, or the square root of 3. So I get 9 times the square root of 3 in the numerator, and square root of 3 times the square root of 3 just gives you 3. Or it gives you the square root of 9, and the square root of 9 is 3. You can go ahead and reduce that, and your answer for x is 2 times the square root of 3. Notice I'm taking up a lot of space for this. Sorry guys, it is going to take up some space. And again, these triangles are not in your notes. You can write these examples, draw these examples in your margins or on the back of your notes. Okay, so in this case, our x is going to equal 2 times the square root of 3. And now that I found x, I can very easily find 2x. And so my c is going to be 4 times the square root of 3. Are we good there? You might want to pause this and jot those down. I'm going to erase it, back up the video if you need to see more. Alright, so that we already covered when you knew the smaller size leg. We covered when you knew the bigger leg. Now what happens if you know the hypotenuse and you're looking for your legs? Okay, what happens here? Remember that your hypotenuse was 2 times your x, and that's going to equal 10. So now that means that my x value, or the length of my shortest side, is just going to be 5. I'm just dividing 10 by 5. So A equals 5. Because my A length is 5, then my longer leg is going to be 5 times the square root of 3. Okay. All right, let's look at some examples. When you have a 45, 45, 90 angle triangle, let's look at this one first. It's the easiest. If you have the side length of 15 feet, then B is also 14 feet. That's a 14, not a 15, guys. then your B value is also going to be 14 feet. And then multiply your C value by the square root of 2. Okay, super easy when you know the leg. It's a little bit more complicated when you know the side length or the hypotenuse. Well, we know the hypotenuse is x times the square root of 2. So that means that our x is going to equal 16 divided by the square root of 2. And again, we've got a radical or a square root in the denominator. We can't have that. So we're going to multiply both the numerator and denominator by the square root of 2. Whoops. There we go. And when I calculate everything out, I get 16 times the square root of 2 over 2 times the square root of 2, or excuse me, square root of 2 times the square root of 2 gives me the square root of 4, which gives me 2. Then I can simplify that further. So my x value, or my side lengths, are now 8 times the square root of 2. So this would be my answer for B and A. All right. All right, so from doing this, you should realize that that when you have 30, 60, 90 degree triangles or 45, 45, 90 degree triangles, no matter what the side lengths are, they are all going to be similar, and you're going to get ratios that are in proportion to each other. So no matter what, if you have the length of your short leg to find the long leg in the 30, 60, 90 degree triangle, you're going to multiply by the square root of 3. This is what the approximate decimal would be. I want you to use the square root of 3. Do not plug in times 1.732. That'll give you a rounded answer. I want your answers to be as exact as possible. If you know the hypotenuse and you're looking for the short leg, you multiply by 1/2. If you know the hypotenuse and you are trying to find the long leg, you're going to end up multiplying by square root of 3 divided by 2. Okay, and then for the 45, 45, 90 triangle, if you know the hypotenuse, you can multiply by the square root of 2 divided by 2. Or if you know the leg, you multiply by 1, or just one leg is the same as the other leg. Okay, so this might look a little bit confusing, and this might be a little bit confusing because it didn't look like this is what we multiplied by. But let's look at it again. I multiplied by the square root of 2 and divided by 2 for the 45, 45, 90. So I'll multiply by the square root of 2, divide by the square root, or by 2. And the same thing for my 30, 60, 90. Oops, I erased it already. But what we ended up doing is multiplying by the square root of 3 and dividing by 2. So the nice thing is now you don't have to do that long process and taking up half a page in math work. Just multiply by the square root of 3 and divide by 2. Okay, last thing I wanted to look at is your COA TOA. Most of you know some old hippie caught another hippie tripping on apples, because this is a school setting, we're using the word apples. Let's see, another hippie tripping on apples. Okay, so what is COA TOA? What does this mean? Okay, if you're looking for your sine, then you take the opposite leg length and divide it by the hypotenuse length. If you're looking for cosine, you take the adjacent leg and divide it by the hypotenuse. That's where your A and your H and the O and the H come from. And then if you're looking for a tangent, you take the opposite leg and divide it by the adjacent. So this is just this right here is just a way to remember what sides of your triangles you're multiplying and dividing by. Okay. So let's look at our ratios. We get, if I wanted to know sine A, then I want to know what is the sine of this angle. It's going to be my opposite over the hypotenuse, or my A divided by C. If I wanted to know cosine A, so cosine is adjacent over hypotenuse, then this is my adjacent leg, and this is the hypotenuse. And then if I wanted to know tangent A, it would be opposite over hypotenuse. Okay? So no matter what trig function you're looking for, sine, cosine, or tangent, anytime you're looking for sine, you're going to do opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's look at our triangle again. Notice we have angle A, angle B, and angle C. Well, what if I wanted to find sine of B and cosine of B? Then now the sine of B is going to have B over my hypotenuse, so the opposite over hypotenuse, so B over C. And cosine would be adjacent over hypotenuse, so A over C, excuse me. And then tangent would be B over A. So notice that this is for cosine B. I know I've said a lot of B's and A's, and it's like, how can I keep track? Sorry, this is the capital letter B here, because I'm looking for the cosine of angle B. Notice this cosine of angle B matches or is the same as the sine for angle A. You will find that when you're looking for sine and cosine and tangent, sometimes you get the cosine of one angle will match the sine of another angle. Okay, let's see. Oh, back to our original examples. I'll try to make this quick. So remember how I said I would prove that the proportions are always going to be the way that I set them up? So let's look at these again. And if I was looking for, see, this is my angle is 30 degrees. So I want to find the sine of 30. So it would be the opposite, or my 8 divided by my adjacent. And I labeled my values already. This was from the original equations, or the original triangles we practice are 30, 60, 90, and 45, 45, 90. So I set up the size. Now let's see if it actually works. So if this is sine of 30 would be 8 divided by 16. So, and 8 divided by 16 is just 1/2. Okay. And cosine of 30 is adjacent over hypotenuse. So adjacent is 8 times square root of 3 over the hypotenuse of 8, or excuse me, 16. So that was just the square root of 3 over 2. And then tangent of 30 degrees would be the opposite over adjacent. So 8 divided by 8 times the square root of 3. And when I do all my math and I simplify and get rid of my radical in the denominator, I end up with these values. And remember, when you were going from one leg to another, if we had the long leg and we're going to the short leg, I think it was, we'd multiply by 1/2. No, hold on, let's go back to it. Yeah, so right here, going from the hypotenuse to the short leg, we would multiply by 1/2. The hypotenuse to the long leg was the square root of 3 over 2, and then the short leg to the long leg was the square root of 3. So that's very similar to our sine, cosine, and tangent functions. Our tangent is a little bit different because tangent is the square root of 3 over 2. we'll kind of get into that later on in our next unit. But for now, I hope you see how these values are related. And then even if I was looking at the other angle, sine of 60 degrees, I could find this here. Notice that now my tangent is the square root of 3. If you want to, you can jot those down. You might want to practice simplifying them. And then if you look at your 45 angles, same thing. See how we're getting the square root of 2 divided by 2 when we're going from our hypotenuse to our side lengths. Alright, so I think that's all we're going to cover in this video. Let's see. Yep, tomorrow we'll work on some of these problems. We will have some fun games, so please watch the video, take down the notes, have your notes with you. You will need them in class tomorrow. Alright, I hope you guys have a great day and fill out these notes.